indices, right? If you have 2 raised to the power of 3, what would be the answer? 2 raised to the power of 3, what would be the answer? 8, right? So the 2 is called what?
The base.
The base, right? Rabbi, the 3 is called what?
Index.
The index. That's nice. Now, from this case now, when you look at logarithm, logarithm is the opposite of what? The indices. It's the reverse of indices. That's what logarithm is all about. Logarithm tells us the power in which a number must raise to. Logarithm tells what? Logarithm the power in which a base, the power in which a base must raise to give us a particular word. Number. Now, if you look at logarithm, we have said that logarithm is what? The reverse of what? Indices, right? And in indices, we have what? We have the base, right? And we have what? The power of index. Then we have what? A number. But at this case, the logarithm is the reverse of what? The what? Indices. Because this guy is already book of what? Indices. So when you look at, let's look at this guy. Now, if you have 2 raised to the power of 3, and they did not give us answer. Now, how can we, if they give us, okay, if you have 2 raised to the power, if you have 2, and we have the answer, how can we identify the base? That's what logarithm is all about. If you have a base, and we have the answer, how can we identify what? The power. So that's what logarithm is all about. It's telling us what? Logarithm tells us the power in which a base must be raised to give us a particular number. Now, if you look at this guy, we don't know what the power is all about, right? So for us to get the power, we use what they call logarithm. And this implies that from logarithm, if you have a raised to the power of x equals to what? N. Now, if you look at this guy, it's already more what? Indices, right? But for logarithm, this is equivalent to what? Log of what? Base a, right? Raised to what? N equals to what? X. Now our focus now is to look at what? Find the what? The power, right? So let's look at how to solve this line step by step. Any question?
No, I'm lost. According to what they teach us, that is index and log form.
Yes, this is indices and this is log. So there are relationship. This is the relationship between what? Logarithm and indices. The relationship. Okay, can we continue? Yes. Now look at type of logarithm. We have what they call common logarithm. Common logarithm. Why is this called a common logarithm? It is called a common logarithm because the base is raised to what? Base what? Is base 10. So if you have log of example 1, let's look at example 1. If you have log of what? 100. Now it's a common logarithm because this log now, you need to understand this log is in what? Base what? Base 10. This guy is same thing as what? Log of what? Base 10 raised to the power of what? 100. Now we're trying to just try to put in a log form. Even though they do not like this base 10, you know that this is what? It's in base 10 because it's a common what? Log building. Now, if you look at this guy, you want to find the power here, right? So let's, because for us to get the power, let's just assume that the power is what? X. Now, if you assume that the power is X, for us to transform this guy, there are two ways of solving it. Either this power now will come on top of this guy, but this is going to give us a complex one. So let me just start from the smaller one. Now, if you have log of 10, this power of 10, it's same as what? Log of what? 10 is the power of what? 10, right? This is the base 10. I know that for us to put this guy in the form of base 10, this guy must be the power of what? Because 10 times 2 will give us the same thing as 100. Any question? 10 is the power of 2 is what? Is 100. This is the same thing as this guy. And now this is leading us to what they call power law in indices. But we're going to look at the law later. Now if you look at if a base is base of power, and that power is equal to another power, this power now will come back of the law reading. And look at what? 10 is power of 10, right? And this guy is already in form of what? Log of base. This log of base is called log of base. We have log of base A to base A is equal to what? 1. When we have the same base, it's the same thing with the power, it's what? Equals to what? 1. So this implies that 2 times what? 1. But this guy is going what? 1. So I will have to this is the final answer.
How will 10 so then there's 100 come to this one?
This guy?
Yes.
Well, no, this is log 10, right? And this is natural log 10. Common log, right? This is log 100, right? Log 100 is already in a form of a common base. This is 1s, which is what? 10. Or let me just explain this. We have log 100, right? There's other way of solving this guy. Log 100. Now if you look at log 100, it's the same thing as what? Log of what? 10, right? Also get 100. 10 times 10 is equal to 100, right? This is the power of 2.
Instead of writing
yes. Instead of writing, it's already in form of what? 10. This is another method of solving this, another second method. Now you know that log 100 is same as what? 10 is power of 2, right? But 10 times 10 is equal to what? 100. Now in this form, that's very power of law of logarithm. By the law of logarithm, the power said that the power will multiply what? Will multiply the log. So I look at this guy is going to do what? Times log what?
log 10.
Log 10, right? Now if you look at log 10, it's already in what? In a natural form. I don't know if you understand. This guy is the same as what? There's a invisible block of what? 10 here, base of 10. This is 2 times what? Log 10 is the power of what? Any question?
What are you going to give log 20 without writing the base? Will the base always be 10?
Yes, if it's common, we call it common when just in this form. It can be log 1000, can be log
500.
log 10.
It must be 10. What are is 2000?
Okay, we are going to solve that one. Let us start this one. Any other question? So now let's look at what we are saying. We have what we say this is what common log. And in common log they gave us an example, say log 100, right? For to solve this guy, for to solve this log 100, you know that it's already in natural, it's already in base what? 10, right? So we are having log of base 10 is power of 100. And for us to get 100, you know that 100 is what? 10 is power of 2, right? And by law of log if a log of base, this one that base, the power now will come down and multiply what? The log, right? So this power now will come back of this log and multiply this down. Now if you look at this log of 10 square of 10, it's already in what? A base of, it's log of a base. Because the same base is also the same power of the base, right? So when the log goes to the same base of the form, it will give us 1. We are having 2 times what? 1, because all this time become what? 1, let's say all this time. Let's look at example 2. We have log of what? 1000. Now for log of 1000, what will be this? Let's look at the solution. Log of 1000 is equal to what? No, this is what natural, this is already common base, right? This is log of what? Base 10, right? This is what? 1000, right? Now, this implies that log of what? Base 10. Once we get this guy to be in form of base 10, right?
Yes.
Is it going to be what? 3, right? 10 square of 3. No, this guy now, in log, is raised to what? Power. So the power will come down and multiply the log, right? 3 times log of what?
10.
Now if you look at this guy, it's already in form of what? Log of base. Because it's log of base, because it's the same base raised to the same what? Power. So this implies this guy is in form of what? 1. So I will have what? 3 times what? 1. Which is going to be what?
3.
Okay, people should do this one. Example 3. Log of base, log of what? This log. Okay, let's start with something there. Let's go try it.
Yes,
Okay, let's go try it. You see, there are some people ask. So this guy is going to be what? People are mathematicians. Log of what? Base, right? Now, we are going to have what? Log 3, right? Once we get, look at the secret is that find what the power that you need to put on top of this base to be. I don't know if you are following. Look at the number when you put on top of 3, we give what? 27. That is the secret. So the number is what? 3 raised to the power of 3, right? Now this becomes what? The power will come down, right?
3 times 3 base 3.
Right? And this guy is a log of base. Because the base is the same thing as what? Power, right? So this becomes what? 3 times what? 1. What's the what?
3.
Okay. Now I look at law of logarithm. Oh, okay, let's compare the second one, but this is the major one. We have number 2. Natural law. Natural law business. If we have the same thing as what? Leave X. Yes, that's what we call. Call it leave X in mathematics. Leave X. For this, we have the major sum in this.
Is it INX?
Yes. Leave X. Example. Also, by dominant with S, just simple, just like log of with S is the same as what? Log of X. That's why you know just try to consider this and just it's very short. I look at can I print this side? Leave X. Leave X. Natural log.
These two types of common logarithm and natural.
Common. This is the two major ones. This guy is called leave X. Sometimes you can call it an exponential, which is equal to like say exponential. Send us 2.71. Number one. Now if you have, let me start with 3 is power of 2, right? No. 3 is power of 3. Equal to 27, right?
Yes.
Now what did I say is not reading? Check the definition.
It said tells us the power in which a base must be raised to
give us a
give us a
particular
particular
number, right? So in log now we are just assuming that we know how to the power. Our focus is to find what the power, right? Now for us to convert this down, this log is the inverse of what indices. So this is for log, this is for our indices, right? Let me just say this is for index. Now for log now, this will be what? Log of what? Base 3, right?
Yes.
Now the number now, this number now will come to this guy. 27, right? Equals to what? 3. Now how did we get this 3? For what?
From the
No, that based on law of mathematics, based on the operator. This guy is called one arithmetic operator. We show what we call it like. By this guy, let's prove how we got this 3 from this guy. You can use this guy to prove for this guy. Now, so from this guy, sometimes they will not just show you how they get this guy become 3. So you know that from log what? 3 is power what? 27, right? It's the same thing as what? Log what? 3. Now look at 27. Now 27 is the same thing as what? Right? Our major thing is to have a base that will be in form of us. This base what we have initially. I don't know if you understand. Know that we cannot just do something like 4. This is something. So this is base 3. Let's look at power that will also be in form of what? Let's look at a number which is the same thing as this base that will raise to what? A power that will be the same thing as what? 27. That's what logarithm is all about. So we are having this guy. This guy is the same thing as what? The power that will come back of this logarithm and multiply what? Log of what? This is going to be what? 3 times what? This guy has what? 1. Because this is log of what? Base. What the base is the same thing as what? The power. This is base 3 and the same base to the same thing as what? 3. So this guy is what? 1. So this becomes what? 3. And from here now I put that this guy is 3. So this guy becomes what? Equals to what? 3, which is the same thing. Now let's look at people should do this one, number 2. Convert this guy.
Should we work like this or just convert it?
You can just convert it. But if you do like this too, some lecture will give you this, they will know that you know what you are doing. Person that do this thing and person that just converting, they are not the same thing. Convert. Let me start with this guy. Are you supposed to combine the two? Okay, let's do it together. Solution. Please, if you have question, you ask. Number 2, right? You have what?
2 plus the power 3 plus the 3.
Right? Also convert it into log.
Yes.
You're going to have to just write log.
No.
This is what base, right?
Yes.
And this is what power. This is what the number, right? Now you don't put the base first, base 2, right?
Yes.
Now base 2 now, the number here will come on top of what? The base. This is what? Equals to what? This power now will come to front. That's the shortcut of doing it. Understand? But how do we get this guy? Just see. Know that this guy is central short. This is how to convert it. The log of the base. This is log of what? Base 2, right? Now the number is going to be on top of what? The base. Whereby this one is going to be in the front. Because we know that from the conversion, we know that if you have a raised power of x, right, from indices, give us a number, right? Now we said that log equals what? The reverse of what? By log we say that log is going to be what? Log of this same base, right? Whereby this number is going to be on top of this guy. And this guy becomes what? So this is just the simple method of converting it. You have the log of what? The base. Then the power will be what? Come to this one, the right hand side. Whereby this number will be on top of this guy. And this is going to be what the same thing as well. You know that one. We have what? Log of what? 2 raised to the power of what? 8. The same thing as what? What power can we put on top of 2? That will give us 8. 2 raised to the power of 2. So I'm going to have 2 raised to the power of 3. Now, okay, now this guy now, this is log of this base, it's just on that power. The power will be in front of the log, right? Multiply what? And this is log of base. Because the power is same as what? Base. It's going to be what? 1. So I'm going to have what? This is going to give us what? 3. This have to just get. You can solve that this thing. You are already converted. Any question? Any question? This one now, we already understand it now. Now let's look at the law of indices. Law of how to be ladder. But before we move on, I would like us to understand something. Take note of this. Know that in indices, we say that anything is equal to 0, right? It's equal to 1, right? But in log reading, since I did the reverse of log reading, know that I will have what? Let's convert it to log. I will have what? Log of what? Base A, right? This is what? This is what?
That's log 1 base A.
This is, we are converting this guy to what? Log reading.
I mean, they want to show now.
This is log of what? Log 1 base what? A. Equals to what? 0. Because by log indices, anything that's equal to 0 is what? 1. But in log reading, we are doing what? The reverse. Whereby we are considering the base. Now the number that will be on top of what? The base. Whereby the power becomes what? Our answer. Any question? So if you see something like this guy, anything is power of 1 is what? 0 in log reading. Whereby indices, anything is power of 0 is what? 1.
That's flexible.
No, this is not. It's not like this is a basic word. Most people know about just to define log reading. Now let's start. Law of. And then the second one, let me put the second one. I'll already explain this time. The second one, if you have log of what? A, right? Raised to A. It's the same as what? 1. Right? So just take note of this guy. Take note of this guy. What I'm going to use to solve so many words.
I know this one. Yes, another one.
This guy. Okay, now, you know that log we have is in the reverse of indices, right? We have already done indices before we come to log reading. And say in indices, if you have anything small of 0, right, it's 1, right? Now, we are trying to convert this guy in form of log reading. And also convert this guy in form of log reading, we say that we are going to consider calculated the log of the base, right? Which is this guy. Now the answer that we got from indices is going to be our power. Our power is going to be what? Our answer. So we are converting this guy. You see our log of what? Base. A. So our answer now comes on top of what? Our base. Our power become what? Our answer. In log we are considering what? The power.
So this log A base A equal to 1. We are converting it to indices.
Log what?
That one is it.
Log A base what?
A equals to 1.
Okay. Because the combination of what? Logarithm. Now, if you are converting to indices, if you are converting this guy to indices, this is going to be what?
Log A.
This is going to be what?
Log A.
It's going to be log of, it's going to be indices. It's not that log. It's going to be indices of what?
A raised to power 1
1 equals to what?
equal to A.
The reverse, they are going back. This guy, this now this guy is the what? Power, right? Will be on top of this guy. How about this guy here? This guy now on this side. Any other question?
No.
Okay, let's look at the law of indices. Please, if you have questions, ask you. This law is always, just pay attention. It's somehow complicated, but you need to pay attention to it. Now, if you have, let's look at logarithm. You have three major laws of logarithm. Number one, you have the product law. You have the product what? Law. The product law, when you have product, like about multiplication, right? So if you have log of what? A and B, right? Log of A and B is the same thing as what? Log of A, right? Plus log of what? B. Now sometimes they can give you this guy to convert it into this form, and that's called the quantization of logarithm. I'm going to look at that if time permits. Now, let's look at example. Example 1. You have log of what? Log of 2 times 3. The same as what? Log of what?
2 plus log of 4.
Log of what? 3. Very simple, right? Example 2. You have log of what are you going to have?
Log 5 plus log 3.
Log 5
Plus log 3.
plus log what? 3, right? Very simple. But when I go to solve, it's going to be what? Complicated. Now if you have example 3, because of the question, example 3, if you have log of it's going to be what? Log of xy is going to be what?
Log x plus log y.
Log what?
X plus log y.
Correct. Okay, let's look at example 4. If you have log of 2xy, what are you going to have?
Log 2xy.
Log what?
Xy plus
Log what? Log 2xy. Log what? Log xy.
log 2 plus log xy.
Log 2 plus log what?
xy.
xy. Like this, Abi. You agree? You agree? I tell you, you agree.
No, I don't.
You agree?
Cancel the y, then plus log y.
Okay.
Cross what?
Log y.
Log y.
Yes.
Correct. We are trying to simplify them. This is product. Log 2, right? Plus log what? S plus what? Log y. Let's look at the fifth example. What I'm doing is go to apply this log, this product to this only case. If you have log of what? Let me check into capability.
Is that 7?
Log of x, y, z, 3.
X, Y, Z.
3.
Log
Log X plus log Y plus log Z plus log 3.
Log what? We can start with 3. What's number with what? Number before alphabet, right? Log 3 plus what?
Log X plus log Y plus log Z.
That's nice. Any question? Now we're going to look at very heavy one. Okay, can I play inside? Now let's look at the second law. We have quotient. When we talk about quotient, we are talking about when a number is formed for fraction, right? It's called quotient. Quotient law, like a division law. When a function divides another one, we have log of what? A over what? B. The same as what? Log of A minus log of what? B. This is called quotient law. Look at all division law. They are the same thing. Now, this law, now look at example. Example 1. We have log of log of 3 all over 2. What are you going to have?
Log 3 minus log 2.
Log of 3 all over 2 will be what? Log what?
Log 3 minus log 2.
Why is it log 3 minus log 2?
Because of the division.
The division. Why did not put this? Why did not put as log? Why can't you start from log of 2 minus log 3? Why did not use this one? Use this one? Huh? 2 can minus 2. But what if the question was here was 2 and here was 3?
Start from the 3.
Huh?
Start from the 3.
Start from 3. No, that is wrong. Let me explain it. We start from the up one. Nominator before the denominator. So this guy is not accepted. We start from the first one. This is our A. This is our B. So the A must subtract from what? The B. Even though this guy is, like, let's look at example 2. Let's call this one example 2. We have what? Log of what? Let me just say 2 all over 3, right? This will give us what? Log 2 minus what? Log 3. Don't make mistake and say log 3 minus log 2. Because we are taking the first one, subtract by the downside, right? So that is the right way of doing this, solving this question. It's not because of 2 is greater than 3 is greater than 2. Hope you are following. Let's look at something very nice. Now we have example 3. Log of 8xy all over what? xy. What will be our answer? Let's look at the solution. We have got log of what? 8xy, right? Going to give us what?
Log 8
8 what?
xy
Right?
minus log 4xy.
4 what?
xy.
Right? But you can still simplify it further. But this is the right word made up for solving this guy. But for us to simplify it further, what are you going to use? For us to simplify this guy is already in form of product, right?
Let's simplify it. Okay, let's say 2 to the power 4.
No. Before you use 2 to the power 4, this is center, so this is product. This is product. So by our product, by product. By product law, right? You know that from this question, I have what?
Log
8xy, right? This thing is center as what? Log 8, right? Plus what?
log x.
Log what?
X.
Plus what?
Log y.
Y, right? Now let's simplify this guy. We can still bring it more, down. We can leave it in this form. We can let the 2 is power of 3. Right? And let's say log of what? I hope we are holding. Plus what?
Log x.
Plus what?
Log y.
And this guy now is what? This guy will come down here. We have what? 3 of what? 2, right? Plus what? Plus what? Plus y. You try that. Equals to this guy, right? Now let's look at the second one. That what? 4xy, right? The sentence was
Log 2 is to power 2.
log 4, right? Plus log what?
Log x.
Plus log what?
Y.
This guy is sentence was
Log 2 is to power 2.
plus what?
Log x. Plus log y.
This guy come here.
2 times log 2 plus log x plus log y.
Plus what?
Log y.
Now you can just add them together. You can just subtract them if you want. Now, but normally this is what just stop at this point. But I don't try to simplify it. If you want to simplify, if they ask you to simplify it. Now this implies that what do you have here?
Log
Log
Our log 8, right?
x.
Minus what?
Log 4x1.
Note that log 8, what do you get from log 8?
3 log 2 plus log x plus log y.
3 what?
Log 2
3 log 1, log 2, right?
plus log x plus log y.
Plus what?
Log y minus 2 log 2.
2 what?
2 log 2.
Now don't forget to put this bracket. Minus what?
Is it minus? Okay, minus.
2 log 2.
2 log
2 plus log x plus log y.
log what?
X
Plus what?
plus log y.
Let's look at what we are going to have. Expand this right hand side. You see how this guy, right? No, this man was apply everything in bracket, right? Apply this guy. you look at this, line, right? It's the same log 2, right? The same log 2. One that their coefficients were different. 3 minus 2 is what?
1.
So what happened?
Log 2.
Right? Look at this line.
Plus minus is minus.
This is Atari.
Is it cancel out? That one to cancel out.
And therefore, if you want to simplify this for what? And not that time we have to just simplify the dot. But this is how we have to stop. When we ask to simplify it, this is how to simplify
So
it.
also, if you are giving a common logarithm, they said if it is given as log 100, then we should assume it already has base 10.
Base 10 years.
So like now that we have, there's a place we go to, and we had log 8.
Log 8.
Log 8 ahead.
Log 8 is not this. We cannot write with 10.
Base 10.
Because 10 now, you can't convert 8 to have another base, which is 10. There's no number that can be on top of that will give us that base 10. You know that we're having two different bases. You have a natural, like, look at this there. If you have log, maybe let's say log 1000, right? If you look at log 1000, you know that this is our common base, which is the same thing as log 1. Now, this is our initial base, which is 10. This guy is going to give us a base. This one a power, right? So we are having, but that base must correspond to this first base. I don't know if you understand. So we are simply to have a log of our initial base, which is base 10. Then this, what can we put in base 10 for this second base we are looking at? What can we put in base 10 for this second one that can give us 1000? It's 10, right? Let me just say our focus is already on the same base 10, right? But now which power can we put on this base 10 to give us 1000? It's 3, right? It's 3. So this guy has what? 3 times. What's the word? 3. But in case of the half, let me just say log of what? 8. Now if you look at this guy, if you assume that this is our natural word, this is our common base, right? How about? If you look at, there is no number that can equate it to give us, that we cannot do something like to be in the same form of 10, no number. So what you just do is just use this as a calculator and just do log of 8 to give you a particular number. Okay, follow, we are going. Okay, let's look at second example on. Okay. Example 4. I'm sorry. Okay, let's solve this guy. Can someone do it? Okay, let us solve it together. Now this guy now this what? By what? Question what? Think about question, but think about what division. But question no, we know that log of what? A over B, right? What's the what? Log of what? A minus log of what? B. So from here, so log of what?
what's that? Is that like x24?
Where?
Oh, x squared
It's not
y.
four.
X squared y. What about the down one? That's it.
Z here.
Now you have to Z.
Okay, let me cancel it.
7 now.
Okay, I should write it like this.
Number z.
Okay. Right? Are you able to?
Yes.
Will it become what?
Log.
Will it become log of?
X squared.
Square, right? All about what? Z cube, right? Become what? Log of what?
5x squared.
5x what?
Y. X squared y
Minus what?
log of x
Z
cubed.
cube, right?
You don't put log. Not log.
Sorry. Log of what? Z cube. Now if you look at from this guy is what we simplify, right? Because it's a form of what? Product. Now, also simplify this guy, I will have what?
Log 5.
Log of what?
5
5, right?
plus log of x squared.
Log of x squared, right?
Plus
what?
log y.
Any question?
No, let's check again.
Any question? Minus what?
Minus log z. Z squared. Cube.
Let's see value. Now if you look at it again, this guy is already form of what? Power law. Or we're going to consider power law after this quotient law. So this power law now says that this power will come from one in front of what? The double digit, right? And we shall have what?
Log 5.
Log 5 plus
2
what?
times log x.
2 times log what?
X.
Right?
Plus log y.
Plus what?
Log y.
Minus what?
3 times log z.
This is the final answer. Any question? And then give people class work. Then you move on to the next one. Can I come inside?
Yeah.
We're supposed to do this one. Okay.
Should we simplify?
You can simplify, you can just stick it. Anyone is correct. You're done? Okay. Are we all done? Let's all do together.
Let's go.
Backward.
3ab squared over c raised to power 4.
Right? This is going to give us what?
Well, 3ab squared minus log c raised to power 4.
Now, this is like this particular part now. It's called what? The equation what? But now, if you go down, it's called simplifying. Now, if you understand, at this point now, just like quotient function part. This is the equation, the main formula part. But for us to simplify this guy now, let me put it. Now, for us to simplify it now, at this point, if you stop at this point,
You are correct.
you are correct. But now we are simplifying it, right? Because we are doing two things at the same time. Now, for us to simplify this guy, we have what? This guy is already form of product, right? But they are multiplied themselves. So we have log of what?
3 plus log a plus log b squared
This square, right? Minus what?
log c raised to power 4.
Oh, 4, right? Now at this point, this guy already in a common form, right? So he having of what?
How about the
Log b now, b squared.
This is log B square, right? Minus 10. Now, you have what? Log A, right?
Plus log a plus log
Log A.
plus log
This is already form of power, right? This will go what? 2
2 log b
log B.
minus
minus
4 log c.
Correct. And this is the final answer, right?
Yes.
But if you stop at this point,
And the right c.
oh, sorry. 4 log C.
Yeah.
I'm sorry. So this is what?
Final answer.
At this point, you just simplify it. But if you stop at this point, it's good, but you can simplify it further. Now let's look at something very important in logarithm.
Let's go. What's the important first? I go fix my face for us.
We ask you to evaluate. Number 1. Okay, now let's look at how to evaluate this guy. Are we together? Now if you look at, they give us what? Base, right?
Yeah.
And they give us what?
Power.
A number. You do not know the power.
Okay, that's just number.
Now.
It's always that
The power.
it's always that logging doesn't have power. You have to find it.
Find the power. Now you need to find the power of this guy that will give us the base. I don't know. What is logarithm first? You need to understand what of this other part so you know what you are going to get for. What is logarithm?
So we do some.
It tells us the power in which a base must be raised to.
You need this base to give us a particular word.
Number. Okay, so that was the number, not power.
Let me just say, okay, now let's look at that if I evaluate this guy. Solution, right?
Yeah.
This is our question. As we have what? Log of what? Base 4, right? This is what? 16. Now the number 16. Now since we are looking how to evaluate this guy, say we should evaluate it. We have what? Log what? 4 to the power 16, right? Now we are looking for what? X, right? For us to get this X, we don't know what the power is all about, right? So we have log of what? We have what? We are trying to put this guy in the form of what? Indices. So this our power will be what? Right? The form of what? Now it's already in the form of what? Indices, right? Now, but we are looking for the value of X, right? You see how what is power of what? Our aim now is to look at a power that one is to the same base of what 4. One is to have the same common base of what 4, right? This is going to be what? 2, right?
Yes.
Now if you look at this guy, they have the same base. See, they have the same base, this guy will cancel out this guy. So our S is not what? Any question? Our aim now was to evaluate logarithm. We are trying to convert it into what indices for an index form. This is already form of what indices, right? Logarithm. So now I try to convert it to form of what indices. So when you convert the form of indices now, what? Yes, what to evaluate it? You convert the form of what indices. Yes. Converting to indices, then look for the common base. Now when you get the common base, now you cancel out the common base and get the what?
So I don't just respect the common logarithm.
Common logarithm will be the same.
Now look at example 2. If you have, they say evaluate. Okay, can you do this one? Yes. Already log of what? Base 2 raised to what? 8 equals to 2. Equals to y, right? Log of what? Log of 2. Y. Don't convert it to indices form.
Yes.
So we have what?
Log 2 raised to power 1 equals to 8.
Coming to what? Our base, right? Yeah. This is our power is what? Indices. And this is what? Our number. Now this guy is what? Now push. Our aim is to put this guy to have the same base with this one, right? So what number can we put on top of 2 to give us 8?
3.
Right? Yeah. So now see they have the same common base, you can solve.
So y equals to
Correct. Let's look at the third example. Evaluate. Right?
plus what?
X.
5x.
Just understand the concept is very simple. Log of what? What's the X at the? Now we convert it to indices. This becomes 2 what? X equals to what? 32, right? Now we are having for this place now, we have 2 let's go of X equals to 32. Now our head now, what number can we put on top of this 2 to give us 32? 5, right? So 5 is 12. 2 is 12, 5 is the same thing as 32, right? Now we cancel what? We cancel the same base, right? Cancel it at the half of 5. Which is the final one. Answer. Now let's look at which one should do this one. Example 4. Log of what? Log of base 5. 265 plus what? Y.
It's 625.
Yes. Let's calculate the account. Oh yeah. Correct. This becomes our solution.
You just looking for
This becomes now our question now is that whether the base here, right? Let it be the same base. Now what now can you put on top of this base part to give us this one, right?
Yes.
Now you cancel out the common base, right?
Yes.
How is it? So that is now let's move on to expansion. Expansion. Right after expansion of logarithm. Now after expansion of logarithm, the same thing we have done. Now also expand this guy, just simple. This is log what? Log 5 right plus what?
log x squared
Plus what?
log y.
You just
According to product.
the same thing, just when you say expansion, you don't know what to do. Evaluation, you don't know the concept of evaluation. When I do the evaluation, we are converting into what? In this, then look at what the common base, right? Now we go about expansion, it's just like what we did. Now, we have what? Log 5, right? Now this guy now will come to this side.
Log 2 x.
2 log what?
2 log x.
Plus what?
Y. Log
Y,
y.
which is the final what? Answer. Let's look at second one. Expand what? Log of what? What to expand this guy? Go back what? Log of what?
Log 3 a cubed b squared.
It's equal to what?
Log 3.
You keep right? Log, sorry, log what?
Log 3
Log 3 right? Plus what?
a cubed
A cube.
plus log b squared.
Since I expanding this, I will have what?
Log 3 plus 3 log a.
This 3 and come back up. That what?
3 log a plus 2 log
2 log what?
b.
Alright, and this is what? The final answer. Before you look at the simplification of the logarithm, it's supposed to give us the last law of logarithm, which is power law. Can I do this side? I won't get anything for the class at all. Which one?
The last one. Why is it the last one?
Yeah, this one. No,
first one. Yes, okay.
No, it's not 3. Sorry. Not 3. Now look at that. Let's look at the third law of love video so that I make mistake as well. Give you equals 1. Point equals. Third law of love. Power law. Power law. Power law is the last law.
This is the rest now.
Look at the power law. Power law says that if you have the law, there's some power. The power law will come at the corner of the W, right? You have to follow this law. So the W we have already done this thing. Lot of laws. This guy is going to be a solution. Forward. 2 log of 1. The second one, example 2. If you have log of 100, right? This is the power of 3. So you should have answer. It's very simple. We are not going to waste time on that.